Hello everyone. Today we're going to be starting a new topic to do with functions and graphs, and we're looking in particular at modulus functions. The definition of it flashed up on the screen just at the very beginning of this video if you want to go and look back at it. But basically a modulus is a bit like, I think of it as magnitude from mechanics, where we're just interested in the size of something, not whether it's negative or positive. It's going to start quite simple. We're going to do loads and loads of examples, ramping it up. So let's get on with it. Right, so this is what we're looking at first of all. So just looking just like a magnitude thing, a modulus, just with these two straight lines either side. So write those down, have a little guess of what you think it might be, and then have a go. So remember, negatives just become irrelevant, it's just the size of the number. So -2 just becomes 2. 6.5 is already a positive number, so that stays as 6.5. A third take 4/5. Well, first of all, we need to work that out. So a third is 5/15. 4/5 is 12/15. So if I take 12 from 5, that would give me -7/15. But it can't be a negative, so it's just 7/15. Okay, so this time we've got a modulus inside a function. So if you want to write down the values of the function when x is equal to 5, what we need to do is start off by, well, 2 5s are 10, aren't they? So that's 10 take 3 plus 1. So 10 take 3 is 7, plus the 1, or the modulus of 7, that's a positive anyway, so it makes no difference. So it's 7 plus 1, which is 8. Have a little go at what happens if x is -2. Pause the video, all that stuff, and moving on. We've got, well, -2 times 2 is -4 take 3. And then plus 1, well, that's going to make -7, which we then add 1 to, but because it's a modulus, it's actually just 7, so we still end up with 7 plus 1 is 8, so we've got the same answer. And one last little one for you to have a go at. What if x was 1? So 2 times 1 is 2, take 3. 2 take 3 is -1, so we're saying, right, what's the modulus of -1? That's 1. So then we need to add 1 to that, and it gets us to 2. As soon as we start dealing with functions, before you know it, we're going to be graphing these things. So instead of having a function of x, you may have y equals. So in order to sketch that, you would start off by thinking about what you would do for just y equals 3x minus 2, and then introduce the fact that y can never be negative. So it's going to create, well, let's have a little think about what might happen. You might want to have a go and see whether or not what you do ends up the same as myself. So I'm just going to sketch in here. I've got my squares, so I'm going to use one for each. So I'm going to say that's -2 there. There's my x-axis. Right, so if I was going to sketch y equals 3x minus 2, I would start at -2, and then I would think about my gradient going across up 1 2 3, across 1 1 2 3, across 1 1 2 3, and then I would be drawing a straight line through here. But I'm just going to put a little dot here because this isn't what I want anymore. Everything that's dotted below is going to be reflected above as it becomes positive. So the easiest point to pick out would be that one there, the 2. And then I'm thinking, well, my gradient's going to be -3 instead of +3. 1 2 3. So if I put a little dot there, I can then carefully just draw straight through like that. So that is the graph of y equals the modulus of 3x minus 2. So now that develops into something like this. Solve the equation modulus of 2x minus 1 equals 5. So more than one way you can do it, but we're going to start by sketching a graph. Always a good idea to sketch a graph first of all, just to think about what's going on. So if I'm going to sketch the graph of y equals 2x minus 1. So if minus 1 is there, that means I'll be going across there, and I've got a gradient of 2, haven't I? Now that's going to be coming in and hitting the x-axis and then bouncing back, so that would go to there and to there and so on as we go across. So that's going to look something like that. That's going to be y equals 2x minus 1, y equals 2x carrying on down there. And because it equals 5 and not just y, that means we're not looking for the roots, we're going for 1, 2, 3, 4, and y is 5. That'll actually be that solution there, which is x equals 3, and that solution there, which is minus 2. Now in an exam you won't have squares, and you probably won't have nice solutions, or you probably won't have a bounce point exactly halfway in a square like this, which makes it easier. So we do need to be able to do it algebraically as well, but drawing the sketch always makes sure that you're in the right area and you know basically what it is you're trying to do. So there are two different solutions here. So how do we get both of those? Well, if we start off just looking at 2x minus 3 equals 5, so 2x minus 1 equals 5, and not worry about the modulus part of it. If that was giving us something positive, then all we need to do is solve that. So that goes to 2x equals 6 if we add 1 to both sides, and then if we divide by 2 we get x equals 3, which was one of our solutions there. And the other thing is, you could get 2x minus 1 if this was negative and then it was being reflected. So we do that by just putting it in a bracket with minus 1 outside. In fact, a lot of people don't bother putting the 1, but I think it's sort of just extra safe. So then if I expand that bracket, I get minus 2x plus 1, because you've got a negative times a negative, equals 5. Now if I were to take 1 from both sides, I'd get minus 2x equaling 4, and then I've got x equaling minus 2, but because we're dealing with the modulus, no, not because we're dealing with it, that is x equals minus 2, yeah, of course it is. So we divide by minus 2 and we get, when x is minus 2, it's going to produce the positive value of 5 from y. Have a look at this one. We've just got 2 examples to go now. Have a go at that. What you want to do first of all is you need to sketch y equals 3x take 5 and y equals 2 minus a half x, and then it'll be a simultaneous equations idea. So if we go for 3x minus 5 first of all, I know that's going to be taking me right down to, put minus 5 down there, 4, 3, 2, 1, 0. So a gradient of 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and there's my first part there. Now that's going to reflect, so that point's going to reflect 2 up to there, isn't it? And that one's going to come up at 5. 1, 2, 3, 4, 5 being just there. So there is y equals 3x minus 5, and then y equals 2 minus a half x. Well, there's our y-intercept, and then gradient of negative a half along 2 down 1, along 2 down 1, along 2 down 1. So we are going to be having the line that crosses just there as being y equals 2 minus half x, and that one is there. So we're looking for these 2 points here. Now that one looks like it's x equals 2. This one here is a tiny bit more than 1, which is why we need to be solving these in the same way that we did the other one, algebraically as well. So have a little go at that. The first one is just going to be if it's positive, so you've got 3x minus 5 equals 2 take half x, or x over 2. So if I add x over 2 to both sides, I get 3.5 x, and if I add 5 to both sides, I get 7. And then if I divide by 3.5, that goes exactly twice into 7. So I found the easy one there, and the slightly trickier one when you've got negative 1. So if we go for negative 3x minus 5 equals 2 minus x over 2. Start by expanding this bracket, gives me minus 3x, and negative 1 times negative 5 gives me plus 5, is 2 minus x over 2. Now this time if I add the 3x to that side, and I take the 2 from there, taking 2 from 5 gives me 3. Adding 3x to minus a half x gives me 2.5 x. So then x is going to be 3 divided by 2.5 x. Well, that's 5 over 2, isn't it? So that is 3 times 2/5, which is 6 over 5, or 1.2, which does make me feel quite happy, because that must be about in the right place. And finally, where we have equations, we can also have inequalities. You may want to have a little go at this before I even start on it. And so the first thing to do is to have a little think about the graph of it. Now you can put both of these graphs into the calculator just to start you off, but you've got to get the modulus one. There is a way of doing it on the calculator. I can show you, but to be honest, I'd rather, for now, we're just concentrating on doing the sketching and thinking about what's going on with it. So 5x minus 1, 1, 2, 3, 4, 5 is going to be going straight down to there, and then it's reflecting in there, but we know it's going back to there, don't we? And then it's going to have the opposite gradient, so it's going to be a negative 5 1, so it'll be 1, 2, 3, 4, 5. That'll actually be up to there in terms of how steep that's going to be. So that's going to be my y equals 5x. So that is the y equals 5x minus 1. And then y equals 3x is going to be starting there and going up 1, 2, 3. So maybe use a different colour because this is going to be quite confusing to look at. It's going to go through the origin. So something like that. So we have got values here and here, both somewhere between 0 and 1 to try to find. First up, if you've got 5x minus 1 equaling 3x, we could add 1 to both sides and take 3x from both sides, and that would give us 2x equals 1. Therefore x equals a half. So that's that one there when it's the positive version. And then the other one is going to be when it's negative, isn't it? So if we do that as well, we go minus 5x take 1 equals 3x. So these both need to change to negative 5x and plus 1 equals 3x. So if I add my 5x to one side, then x is going to equal 1 divided by 8, which is 1/8. But I haven't finished because that is only if it's an equation. It's an inequality, isn't it? So let's have a little look back here. Which one of these is meant to be bigger than the other? So the modulus is larger. So I am interested in all the values from this side here and also from here. So we are looking at x when it's bigger than that one and when it's smaller than that one. So we need to, so we've got x is bigger than a half, we've got x is smaller than an 8. So it's that or that, isn't it? Which we could write. I wonder if you can remember the old set notation thing, how we could do that. So that has the funny brackets in it, doesn't it? So defining x as being bigger than a half. And what symbol means or? That's the union one, isn't it? And x is smaller than an eighth, or x is smaller than an eighth. It doesn't matter which way round we write those two. Right, now we do need to do some practice of this. So like last week, I will post up the questions for those of you who haven't got the book on class charts as well. And the questions I'd like you to have a go at are on exercise 2A, which is on page 26, and we're looking at question 4, A, C, F and H. Question 6, parts A, C and E. Those will get you both quite well practiced in different things, and then the exam style questions are question 8, 10, 12, 13. We've done quite a few examples, so if you feel confident enough to jump straight onto the last 4 there, then by all means do that. Okay, see you tomorrow, folks.